Hello, and welcome to another recording on Azure Stack. This is Platform as a Service in Microsoft Azure Stack. My name is Mark Grimes, and I'll be presenting this section. In particular, we're going to focus on SQL Server Resource Provider and the MySQL Server Resource Providers in Microsoft Azure Stack. I have a couple easy to remember and easy to use shortcuts also for these for your reference, aka.ms/azurestack/SQL and aka.ms/azurestack/MySQL. For our agenda, this is what we'll look at, is primarily understanding what the SQL and MySQL resource providers are, what they provide for you, how to install and configure them, and look at architectural overview and the deployment overview of these resource providers. Let's start with the resource provider concepts and overview. In some of my other sessions, we've talked about this a little bit, but when we provide services to our customers, whether internal or external, there are a few primary ways we do this. You can have IaaS virtual machine templates that we can download from the marketplace, and we had a session on Azure Stack Marketplace that talks about how to do that. Also within that context, you can either download and or create custom ARM templates or Azure Resource Manager templates. But in either of those cases, if a customer pulls down and uses those, we call that's their pet. If they have 10 virtual machines, they have 10 pets to independently maintain, manage, update, patch, etc. When you have a resource provider, which is like we do in the public cloud service as well, and we think of that as platform as a service versus what I was just talking about with the virtual machines and templates, which be more infrastructure as a service. When we have platform as a service using resource providers that you install and configure in Azure Stack, you now take away that burden of maintaining and managing those images that the customers otherwise would own as their own pets. By providing a platform as a service, it makes it simpler for them. Now it puts a little bit more administrative overhead for you, but we update and patch these one time or at a certain interval, and then it takes care of all of our customers. So that's why people like platform as a service, because it's less for them to maintain and manage, and you can control and manage and update and add additional capacity as needed as well, and we'll talk about that later. So what is the SQL Server Resource Provider? It provides Azure Resource Management Access and UI or user interface items, which can be used to manage SQL Server resources to SQL Server running in IaaS. It allows for ARM templates and the Azure Stack portals to do create, read, update, and delete operations for databases, for login settings for the databases, for validation of retrieving hosting servers, and even some of that usage data will be available to operators. The resource provider doesn't provide all of the database management availabilities of Azure SQL database, so particularly for customers used to using those, you need to make sure they have a clear understanding. If, of course, they don't have that experience, then it's just letting them know what capabilities exist. But as an example, elastic pools that automatically allocate resources that we have in Azure in the commercial space aren't supported. But otherwise, all the basic CRUD operations, as we mentioned, are. The resource provider for SQL contains the following components. We have the SQL Resource Provider Adapter Virtual Machine, which is simply a Windows Server VM that runs in the provider services. The resource provider itself, which processes requests and accesses database resources. And then servers that host SQL, which provide capacity for databases, and those are called hosting servers. In order to make this function properly, you must create at least one instance of SQL Server or provide access to external SQL Server instances. So that's an interesting idea. You can have these live and breathe and be built on your Azure Stack operator portal, Or if you have external servers for SQL, you can leverage those as well. Now, the important thing to note here is if you use an external server or an internal one for either SQL or MySQL, it has to be dedicated for this function. So as an example, if you had built app services, which requires a SQL server, you could not use that same SQL server for the SQL Server Resource Provider. That's a very important concept in Azure Stack. Or if you had an external SQL server and it was your fantastic favorite SQL server, but it was used for other things, you can't use that. It's pretty much you're building a SQL server from scratch, and then you leverage that. On the right-hand side, we have some specific Azure Stack considerations. So as we mentioned, we're taking away the burden to the users to update, patch, maintain those SQL servers. But in Azure Stack, because you're playing the role of Microsoft that we do in public Azure for platform as services, in Azure Stack, an administrator will need to manage the underlying IaaS instance of SQL for the patching, performance monitoring, etc. We talked about the external SQL server can be used. The main criteria is that you have good network connectivity that can be achieved from in accessing that. There's no parity with the SQL database on Azure beyond CRUD commands, and we have support for always-on availability groups. Now let's take a look at the MySQL Service Resource Provider. So MySQL databases are commonly used with websites and support many website platforms. For example, you can create WordPress websites using the App Services Resource Provider add-on. So when you install the app services, you actually will see those templates, but you may not have installed and configured MySQL. So this is an add-on capability you can do. After we deploy the resource provider, and this works the same way with SQL Resource Provider, you then can, or the users could create MySQL servers and databases using ARM templates. You could provide MySQL databases as a service. All the CRUD operations, very similar to what we had with SQL Resource Provider, all work the same that we talked about in the last slide. So the resource provider has the following components, again, very similar in the way it works to the SQL. So we have a MySQL Resource Provider adapter virtual machine, which is simply a Windows Server VM that's running the provider service. We have the resource provider, which processes requests and accesses database resources, and then servers that host MySQL Server, which provide capacity for databases. And again, just like in the SQL Resource Provider, they're called hosting servers. You can create the MySQL instances yourself and or provide access to external MySQL Server instances, just like we talked about for SQL. And again, all the same caveats apply. It has to be dedicated for that purpose. You don't share with other MySQL servers, so it's a dedicated MySQL Server instance. Now, this is an important point I didn't mention on SQL Server, but it applies both for SQL Server Resource Provider and the MySQL Resource Provider. So very, very important that the hosting servers that we do in either case must be created from a tenant subscription, not in the Azure Stack Operator or default provider subscription. With app services, we can install in the default provider subscription, but for the licensing for SQL and MySQL, they have to be created in a tenant subscription. So all you have to do is just, as an Azure Stack Operator, you create and can assign yourself an Azure tenant subscription, and then get that UNC path to access that server, and then that can be leveraged. So once you build and deploy that server in there, then you can add it to the resource provider. So very, very important from a licensing perspective for both of these. So why use the resource provider? We've talked about a lot of these. Again, it's a farm hosting environment, PaaS-like. It's a unified experience for all customers of compute resources on your Azure Stack environment. and then provides flexibility of server choice. So as you're building and deploying these, you can set up the different types and flavors of the hosting servers from the OS to the SQL and even the MySQL versions. And we'll talk a little bit more about that. So key benefits, again, less for them to maintain and manage, a little more work on your back end, but you do it once, update it, patch it once, add hosting servers once as needed, and it provides these capabilities for the tenants/users to build business solutions. And again, any version of SQL or MySQL, and we can add capacity as needed. We'll talk about that coming up. Other things addresses common server farm hosting requirements, including self-service access, automated provisioning, configuring. It's a unified experience. And again, we talked about the flexibility. Provides access to a managed SQL or MySQL farm through the Azure Stack portal. And accessible in Azure Stack and can be composed from other workloads as well. So how these work, and it's interesting the terminology that's used. These are simply adapters. So it kind of makes that connection from the client accessing and or creating or provisioning these databases to what exists in the back end in the adapter connection that's been created by the Azure Stack operator. So as we mentioned, it will provide ARM or Azure Resource Management access for templates or in the portal as defined by the administrator. And this adapter is really, it's a process that runs inside the virtual machine that hosts the REST endpoints to provision database objects via Azure Resource Manager. The resource provider itself is not in the data path. It's just involved in the CRUD activities against the database instances. So a single resource provider can host many databases server without constricting the access because they are simply adapters. Again, the hosting server, any server that has SQL or MySQL server, as we mentioned, the admin from the Azure Stack operator will install and configure these either internally in the stack or externally, provide, again, clear network path. And we talked about it can be outside and all the caveats with that. So SKUs, you can differentiate capacity to the tenants. So we could have a standalone SQL server, or we could have always on available set AOA SQL server as well. And these are mainly defined by the servers hosting the databases on the size, even versioning, as you see here. So we have a SQL Server 2014 and a 2016. And again, just like anything that you install from the Azure Stack operator, you have to simply talk to the application owners, find out what their requirements are, and make sure that you have those. Another thing that's really important to note on doing these is that in addition to getting the server prerequisites and requirements, you will also need the SQL Server extension. So very important that you grab that. And that's all detailed out in the requirements section for both MySQL and SQL Server. So setting up database access. We have a whole session that we talked about offers, plans, and quotas. And so if you've already set up offers, plans, and quotas, say, for example, let's say we had a IaaS offer of small, medium, large servers, whatever your flavor of the day is, but you hadn't yet installed app services. So even though that offer still existed, you would either have to create a brand new offer, maybe perhaps just to include the PaaS services, whether it's app services or SQL or MySQL, or we could do an add-on plan as well. So that always has to be taken care of to make sure that we do that so the tenants can provision databases, because if you just go install the SQL resource provider or the MySQL resource provider, it doesn't mean that they can necessarily get to it yet unless it's part of their offer. So let's take a look at the architectural overview. So the admin and tenant spaces, while they are separate, particularly from a subscription perspective, they're both under the same Azure Resource Manager or ARM endpoint. But after we execute the setup of the resource provider virtual machines are created under the admin space, and these VMs are under the admin, so not listed under the build virtual machine. Also, the resource provider extensions are activated under the user interface. So we'll have a SQL tenant for the tenant consumption, a MySQL tenant for tenant consumption. There's the marketplace consideration for tenant consumption via the marketplace. There's the SQL admin for administration on the hosting servers endpoints so that we can make the hosting servers or add additional hosting servers under the tenants. The resource providers do not install any hosting servers by themselves. Again, that's a process that you have to make sure happens. Okay. The SQL and MySQL resource provider portal experience. So this is a snapshot on the right, what it looks like. Very similar for both SQL and MySQL. You add hosting servers, associating them with the SKUs. So on the right-hand side, you see the plus sign where we can do that, and you can put in the capacity, the database count, update the max size. You can remove a hosting server, and that will not delete the data. And likewise, as we mentioned, we want to limit the size of the database and number of databases per subscription. So you can either update the default quota or create a brand new quota for that as well. Expanding capacity, so we can scale out the resource providers, and that's achieved by adding additional hosting servers, as we mentioned, and we saw on the last slide. The admin can automate this process if you're kind of nifty with that using Azure Resource Manager, Desired State Configuration, DSC, or PowerShell. But by default, there is no complete automation within the stack. It'd have to be something that's customized. So as an example, you would have some sort of program or process that would be monitoring. Once you hit a certain threshold, then you could have it create or add additional resources. So that would take a little bit of work. There are some sample ARM templates available on GitHub. And again, when you're looking for those, always look for the Azure Stack Quick Start templates. Do not use the Azure Quick Start templates because they're not going to have the proper match of APIs and all the correct resources that would only be available in Azure Stack. So to get this going, let's talk about the deployment overview and how that all works. So first of all, you got to get your stuff. You got to download the resource provider packages. If you're on an ASDK, the Azure Stack Development Kit, and we'll talk more about that in its own session later. If it's on the ASDK, you're actually installing them on you can use the physical host because it's all kind of one and the same. If you have a multi-node system, the host must be a system that can access the privileged endpoint. So typically, when whoever or however you set up an admin workstation, that is typically your method of doing that. In a perfect world or a desired state world, we like to have that something like a PAW or a SAW, which is a privileged access workstation or secure access workstation. Because you think about this just like a Microsoft admin would access Azure in the back end. We have a very secured systems, and depending on your requirements, that's a whole nother discussion, but you want to make sure that that's a secure system that you're doing these such of privileged operations like on accessing the privileged endpoint. You run the deployment script and then add database hosting service to the resource provider. So let's just look at the docs here real quick. And you can see, and again, very, very similar whether I'm doing the SQL resource provider or the MySQL resource provider. And just as a note, we'll talk a little bit later about removing these if you ever have the need to. It's good to keep this, and this actually kind of makes a nice backup of everything that you need. So at the beginning here, you see all these things, and I'm assuming that by the time you get to here, you've installed and configured all the Azure Stack PowerShell tools, the Azure Stack tools, everything that you need so that we can import these modules to make it work. And then you're walking through these. One thing, not sure the documentation tells exactly, but just a little safety tip. So one of the things you'll need is the IP address of the privileged endpoint. So there is a file that we'll talk about in another session that usually OEM will leave behind. It's called Azure Stack Stamp Info.json. And that's where you can get the IP address of the ERCS, that stands for Emergency Recovery Console, which is the privileged endpoint that's needed to do such privileged operations as installing a resource provider. If you have an Azure Stack development kit, well, that's your name right there. But again, I always like to use the IP address, then we don't have any issues with domain name resolution if that's not all set up properly. In Azure Stack Integrated System, there's 3 of these. So there'd be ERCS 01, 02, 03. Okay. And let's just go back to the slide because then it walks through all the rest of these settings, which look like this. Oops, sorry about that. For example, the cloud admin credential, the credentials required to access the privileged endpoint. Again, you should have those credentials. They would have been left behind by the OEM. And hopefully maybe you reset that password. That's kind of a good best practice as well. But you need to have that. The Azure Stack admin account that you use for deploying the Azure Stack. Quite often in a lot of environments that will be the global administrator in Azure that was used for that. A VM local credential. So you're defining these for the local administrator account. So you're kind of making that up to whatever your standards are. The IP address, we talked about that for the PEP or privileged endpoint, which is the ERCS that you get from your Azure Stack Stamp Info.json file. And another note I wanted to make about that, if you didn't know where that file was or you couldn't find it, if you access the privileged endpoint, you can actually regenerate that file. There's a command line for that. Azure environment. So the Azure environment, the service admin account that was used, the value is right there. So it's Azure Cloud that we're going to use. The only difference would be, and we're seeing a few of these now, so we do have the ability to connect Azure Stack to Azure US Government. So if you're in a federal space, that would be different. But in most scenarios that we run into, it's Azure Cloud. So that means your Azure subscription is in public Azure and not a government entity like US Government or China. Dependency files local paths. So the certificate PFX file would be placed in the same directory where we have all this stuff. You should have had those ideally pre-created at deployment time. It's not required, but quite often when the OEMs come in and they request to have the certificates generated that are required for the installation of Azure Stack, they just have you get all the certificates. And so there's additional certificates beyond the initial install, particularly for platform as a service, for web apps, for SQL and MySQL. If you don't have those, you go back to the prerequisites. It will take you to the documentation about how to generate those. And of course, you'll need the password as well. So if you don't have access to that, you need to have the admin that can get those passwords to get the certificates for you. And there's the password in the next one. Max retry count, again, how many times you want to rerun the operation if there's a failure, and a timeout between retries. The uninstall, that's the option. So as I mentioned when we showed the sample script, you can actually run the command to run that script and do an uninstall. So if for any reason there's any problems or issues, I've done several of these. I only one time had one issue, and we just weren't sure what was going on, so we did an uninstall, and it's a clean way to get rid of it. So it will take away all the stuff that was done. There are some other considerations, though. There are caveats that we'll cover that in a few slides coming up here. Then debug mode is always good, so it prevents automatic cleanup on failure. So you can adjust that as well, or add that switch. Nothing really different. Everything I just walked through and said for MySQL is in here. The only one that stands out to me at the bottom is there's an accept license. So it skips the prompt to accept the GPL license, and there's a link there to read more about that if you are going to do MySQL. So deployment considerations, any version of MySQL can be used for hosting services, so community, clustered, or commercial. Any version of SQL can be utilized, but that's got to be managed by the admin. And keep in mind things like if you want the newer features like SQL Always On support, that requires SQL Server Enterprise or later. So again, getting back to the requirements of the application owners, they say we need this, and you have to look and see if that SQL Server version will support it. So again, if you're in a connected state, these would be virtual machines that you would download and install if you're going to install it in a stack. If you're going to have it off the stack, again, you can do that wherever, as long as we have the network connectivity. Proper licensing of the hosting service is required, and the license cost is not included. The resource provider virtual machines for Windows Server are included, though, so you don't have to worry about those. But again, that's why if you're doing this on the stack, it has to be done in a tenant subscription and not in the default provider subscription in the operator side of the house. You can also leverage VM and storage meters to be taken into consideration for your own use and or for help with customers. Some other deployment considerations, and we talked about some of these. For example, the Elastic databases, we don't have the same features. It's really fundamental CRUD operations. There is no auto scale with this. So while you can add SKUs and advanced capabilities by maybe a newer version of SQL or MySQL, auto scale is just not one of your options. REST API and PowerShell, in this case, do not match Azure SQL APIs. So this will probably only be an issue if you have a customer who's already been there doing that in public Azure commercial space. Then you need to just kind of set the expectations with them. Existing ARM templates for a public cloud that use the Microsoft.SQL or .MySQL will need to be modified. And again, the best way to avoid that is to use Azure Stack, GitHub Quick Starts, and those will usually be adjusted. The last set of bullets here is really an important caveat. There is no resource governor for SQL. So you have to think about this depending on the number and size of tenants you have, and particularly if any of them are database hungry. There is no governor. There's no throttle that says customer A, you can only use 50% because we know you're going to use a lot more than everyone else, and customer B, C, and D, they can use what they want because we know they're going to use very little and not over provision. Noisy neighbors can compete for database server resources. So something to be aware of, and the only thing that you can do is you, just like with any resource in Azure Stack, need to be monitoring the space in Azure Stack, and you can always add additional hosting servers for added capacity. So in a multi-tenant environment, all databases must be unique. There's got to be a one-to-one matching with the databases, and the SKUs are available to all Azure Stack users as we talked about before. So if I make a small, medium, large, SQL Server 2012, 2016, always on availability set, I make it once, everyone will see that. Now to update the resource provider, whether we're doing SQL or MySQL, on that script page, there's actually, the next page following, I believe, is there's an update MySQL provider.ps1 or an update SQL provider script.ps1. So very, very similar in the variables that you populate in there. Now, the one thing that's nice to know, whether we're talking about the MySQL or the SQL resource provider, they have versions as they have been released. So in both cases, starting with resource provider version 1.1.33.0, all updates are cumulative. So if you're brand new to Stack, not going to be an issue because you're going to download the latest greatest. But if you've had your Stack for a long time and the last time you did an update was 1.1.33, you don't have to worry about any incremental changes that may be happening. Now, just as an insight, that's something the product group is working on, but we don't have a defined timeline. But the way this is going to work in the future will probably change. What we're looking to do across all the resource providers is have a unified experience so that we can do these updates through the marketplace. But currently, that has not happened yet, but keep tuned to the Azure Stack updates, and hopefully we'll see that in the future, maybe around 2020. What else here? So from maintenance, again, when you install that resource provider, it doesn't participate in the normal Azure Stack update. So if I go from Azure Stack 1905 to 1906, it did nothing to update the resource providers themselves. Now, when resource provider updates do happen for Azure SQL and MySQL, the recommendation is always to make sure that that is deployed with the most current or related to Azure Stack update. So depending on if you're 1 or 2 versions behind, because we know we can't be more than 2 versions behind in the Azure Stack update, and let's say in that period a new SQL resource provider came out, maybe it came out in the latest version, the recommendation from engineering is always to have the most current version that's recommended for that resource provider update. So you bring the stack up. In this case, let's just as an example say that the latest SQL resource provider said we want 1906. This is just an example, not the way it is necessarily, but if it says it requires 1906 for the Azure Stack system, then you would make sure you did that first, then install the updated resource provider. Some other things that are worth noting too, and there's a whole documentation. You can do a search on Bing for Azure Stack secrets rotation. There are some defined processes for various secrets in Azure Stack. But when you're using the SQL and MySQL resource providers in particular with the integrated system, again, this is the Azure Stack operator's responsibility for rotating these named infrastructure secrets to ensure they do not expire. So we have the external SSL certificate, and those were provided during deployment. We have the resource provider VM local administrator account password provided during deployment, and we saw that in the scripts as far as the parameters you can define. And also the resource provider diagnostic user password, which is also known as the DB adapter diag password. This is another important note that's not really called out per se in the documentation, but hopefully you have a good, well-defined process for keeping and sorting through passwords, because we have a few passwords already as they exist across Azure Stack. But as you do SQL databases and app services, and the app services have their own SQL databases, and they have separate file servers, and then there's other passwords for the app services, you really need to make sure you kind of keep these all together in a safe and secure place and keep track of them so you can rotate them at whatever intervals required by your organization. So that's just been a safety tip I've learned, particularly in environments where I've run multiple stacks, because since they're all under different endpoints, each and every stack is going to have all these various passwords that you have to maintain and manage. So keep track of them in a nice way. Removing the SQL resource provider or the MySQL resource provider. As we mentioned, there's an uninstall switch, which makes it relatively easy to do. And I also talked about that I did this once. and kind of kicking the tires and testing the waters. And the first time I did it, it failed. And part of the reason it failed is because I had done some stuff with it. So if you just installed the resource provider and it's fresh and nobody has used it, and there have been no quotas or offers set up with it, it's going to come undone nice and easily. But as soon as you start doing other things, like you have an offer plan quota associated with it, you have tenants who then use that, and they create SQL servers or MySQL servers in their environments. Now you've got all these hooks and these dependencies. So this is kind of a nice little checklist of things that have to be done. So all user databases login settings must be deleted from the resource provider, and that will be performed by the users themselves. Tenants must unregister the resource provider namespace from all their subscriptions. The administrators must remove the hosting servers from the SQL resource provider adapter. So even that, if you've done the basic install, that would exist, and so you'd have to remove those. Administrators must delete any plans that reference the SQL resource provider. And of course, if you try to do that and SQL servers have actually been created, that will fail, because it will say you have to get rid of the databases first that are tied to this. The administrator must delete any SKUs and quotas associated with that adapter. Then, once you've undone all these hooks, you have to rerun the deployment script that you saved from the initial install with the uninstall parameters, and put in all the variables that you need. So you'd reference the Azure environment, which is probably Azure Cloud or government, the cloud admin credential that's required to access the privilege endpoint, as we talked about in setting this up, and also the AZ credential used for the Azure Stack Service Admin account. Again, that's the same account that you used when you first set this up during the initial deployment for all of Azure Stack, not just the resource provider. Okay, so we've talked a little bit about maintenance. Let's see what else we're missing here. We've covered the patching and updating. Backup, restore, disaster recovery. So the SQL adapter is not backed up as part of the Azure Stack BCDR process because it's an add-on component. So we don't have any scripts exactly, but I do have this. So let's go back to the website here. And just recently, I made a web blog, and it's called aka.ms/azurestack/assessment. And on aka.ms/azurestack/assessment, I have a section that I wrote a little bit about backup. And this is something we're working on with my colleagues, just kind of keeping track of things. If we walk into an environment, we want to check, make sure things are done. But I made a section here on backup. So do you have backup set up? And we talk about infrastructure backup, which we'll describe in another workshop. But also kind of a checklist of protecting IaaS and PaaS resources. So as we scroll down here, we have the platform as a service resource providers, and there are actually some links in here for SQL resource provider and the MySQL. So there's some reference in there, and also it's in the Azure Stack documentation as well. Same thing for the SQL credentials. We talked about the importance of keeping track of all these, particularly if you have multiple SQL servers, multiple hosting servers, multiple Azure Stacks, in addition to all the other various accounts that you have as Azure Stack operators, cloud admins, etc. So there you have it, folks. Some information on creating, setting up, maintaining, managing SQL resource providers, as well as MySQL resource providers. I want to thank you very much. I hope you enjoyed this. Make sure you leverage those shortcuts at the beginning, aka.ms/azurestack/SQL and aka.ms/azurestack/MySQL. My name is Mark Grimes, and I thank you very much. Have a great day. Goodbye.